you ever stopped to think about how magical Wi-Fi is? It's this invisible force that lets you stream movies, scroll through social media, and attend online meetings from almost anywhere in your house. It's like air, but for the internet. But have you ever wondered how it actually works? How does the internet get from a wire in the wall, fly through the air, and land perfectly on your phone or laptop? Well, today, we're going to demystify this everyday magic. It's not actually magic, it's just really cool science. And trust me, by the end of this video, you'll see your little Wi-Fi router in a whole new light. So, let's start with the basics. The word Wi-Fi is actually a brand name, not a technical term. It stands for wireless fidelity, kind of like hi-fi for high-fidelity audio. The real technology behind it is called WLAN, or Wireless Local Area Network. The goal of Wi-Fi is simple: to connect your devices to the internet and to each other without any pesky cables. To understand how it does this, think of your Wi-Fi router as a radio station. But instead of broadcasting music or news, it's broadcasting internet data. Your smartphone, laptop, smart TV, they all have a tiny built-in radio receiver and transmitter. These devices are constantly listening for that Wi-Fi signal, just like you tune your car radio to find your favorite station. Now, how does data get turned into a radio wave? It all starts with binary code. All the information on the internet, every picture, every word, every video frame is just a long string of ones and zeros. Your Wi-Fi router takes this digital language and converts it into radio waves. It does this by rapidly changing or modulating a specific property of the wave, like its amplitude or frequency. A 1 might be represented by a high-amplitude wave, and a 0 by a low-amplitude wave. It's like a super-fast version of Morse code, but instead of dots and dashes, it's ones and zeros sent using invisible light. These radio waves are part of the electromagnetic spectrum, just like the light we see, microwaves we use for cooking, and the radio waves for AM/FM radio. Wi-Fi uses specific frequency bands, primarily to 0.4 GHz and 5 GHz. Think of these bands as highways for your data. The 2.4 GHz band is like a local road. It's been around for a long time, it has a longer range, and it's better at getting through walls and other obstacles. However, it's also more crowded. A lot of other devices use this band, like cordless phones, baby monitors, and even your microwave oven. This congestion can cause interference and slow down your connection. It's like being stuck in traffic. Then you have the 5 GHz band. This is the express highway. It offers much faster speeds and is way less crowded, so you get less interference. The downside? Its range is shorter, and it's not as good at penetrating solid objects like thick concrete walls. It's like the express lane is great, but it has fewer exits and you might need to be closer to an on-ramp to use it. Many modern routers are dual-band, meaning they broadcast on both the 2.4 and 5 GHz bands simultaneously. This gives you the best of both worlds. Your devices can automatically choose the best lane on the highway depending on where you are in your house. Some even newer routers use a 6 GHz band, which is an even wider, faster superhighway with even less traffic. So, your router is broadcasting these data-packed radio waves in all directions. What happens next? Your device, let's say your laptop, has a wireless adapter. This adapter catches the radio waves and does the exact opposite of what the router did. It demodulates the wave, translating it back from a radio signal into the original binary code of ones and zeros. Your laptop's operating system then takes this data and uses it to load the web page, stream the video, or download the file you requested. But wait, communication is a two-way street, right? It's not just about receiving data, you also have to send it. When you type a search query into Google or click a link, your laptop needs to send that request back to the router. So, your device's wireless adapter does its own encoding. It converts your request into ones and zeros, modulates them into a radio wave, and sends that signal back to the router. The router receives this signal, converts it back into digital data, and sends it on its merry way to the wider internet through the physical cable connected to your wall. This whole process, sending and receiving, happens millions of times per second, creating the seamless, real-time experience we're so used to. It's a constant, high-speed conversation between your devices and your router. Now, you might be thinking, if my neighbor also has Wi-Fi, how does my phone know which signal to connect to? And how do we keep our data private? This is where network names and passwords come in. Your router broadcasts a unique name called an SSID, which stands for Service Set Identifier. This is the network name you see in your list of available Wi-Fi connections, like smithfamily_Wi-Fi or coffeeshop_free. When you select a network and enter the password, you're creating a secure, encrypted link. This encryption is super important. It scrambles the data being sent between your device and the router. Without it, anyone nearby with the right tools could eavesdrop on your radio waves and see exactly what you're doing online. That's why you always see that little lock icon next to most Wi-Fi networks. So what's happening inside that little box we call a router? A modern Wi-Fi router is basically a small, specialized computer. It has a CPU, memory, and its own simple operating system. Its main jobs are to manage the network, assign a unique IP address to each connected device so data goes to the right place, act as a firewall to protect you from online threats, and of course handle the wireless communication. But what about when you have a big house and the Wi-Fi signal gets weak in the back bedroom? We've all been there, holding our phone up in the corner trying to get that one extra bar. This happens because radio waves, while powerful, lose strength over distance and as they pass through objects. Walls, floors, metal appliances, and even water and pipes can absorb or reflect Wi-Fi signals. This is called attenuation. To solve this, you can use things like Wi-Fi extenders or mesh systems. An extender simply picks up the existing signal and rebroadcasts it, giving it a boost. A mesh Wi-Fi system is a bit more sophisticated. It uses multiple nodes or satellites placed around your home. They all work together, communicating with each other to create a single, seamless, and powerful Wi-Fi network that covers your entire house. It's like having multiple routers all working in perfect harmony. So let's recap this incredible journey. It starts with data from the internet flowing into your router through a physical cable. The router, acting as a translator and traffic cop, converts this data from ones and zeros into radio waves. It broadcasts these waves on specific frequencies, like 2.4 or 5 GHz. Your device's wireless adapter catches these waves, translates them back into digital data, and displays the content you wanted. When you send information back, the process happens in reverse. All of this is secured with encryption to keep your activity private, and it all happens at the speed of light, billions of times every second. The next time you're frustrated because a video is buffering, take a moment to appreciate the sheer complexity and elegance of what's happening. Your data is literally flying through the air, navigating obstacles, and finding its way from a server hundreds of miles away right to the palm of your hand. It's an amazing feat of engineering that has completely transformed how we live, work, and connect with one another. Wi-Fi isn't magic, but it's pretty darn close. Thanks so much for watching. If you found this explanation helpful and interesting, don't forget to hit that like button and subscribe for more deep dives into the technology that shapes our world. Let me know in the comments what other tech mysteries you'd like me to unravel next. See you in the next video.